kind of ease into related rates. We're basically just going to do this first page today. And this is kind of just to get used to the notation, to get used to the types of problems before we actually do one. And if I were smart, I would have looked at the homework ahead of time, but I'm pretty sure the homework will have similar questions like this, correct? Is that like the first page of the homework? Does it go right into just problems? Okay. Well, I didn't plan this very well. That's okay. I'm also guessing that you guys are probably slightly behind, given that like only 10 people have turned in the homework between both my classes. So with the time here at the end of the hour, I'll kind of go through that and talk to people to see where you're at. Okay, so the first 4 questions is just to learn how to write things the correct way. Not that you don't already, but to get used to the notation so that the bottom half of this page is we're going to be doing the derivatives, and then you'll kind of notice that the notations match up, and that's how we're going to use them. So volume of a cylinder is increasing at a rate of 6 cubic feet per second. I think you guys are probably okay just writing 6 cubic feet per second. But what does that tie to? Like, what would that be labeled as? You got an answer? I was going to give the first one. Go for it.
I have a guess.
Go for
Is
it.
The derivative of the volume?
Yep.
Is that,
So it would be dV dt. So we're going to have to write everything in implicit notation, like we can't write v prime. Well, I guess you could, but you're generally not going to see it. So to me, the easiest way to put this together, because I know some people have a lot of issues with the left-hand side where it says dV dt, is, I mean, like, I go by the label. The label is pretty much what tells me how to write the calc notation. So cubic feet is a volume. And in the problem, it mentions volume. Seconds is time. And so that's where I would come up with dV dt. Okay, 2. Depth of water in a rectangular pool is decreasing at a rate of 2 inches per hour. So 2 inches per hour, we'll just start by putting that. Decreasing would mean negative. Okay? And then what am I going to label it? So what I can do is I know they're both going to be derivatives, and I just need to come up with the correct labels. So what's the top labeling? Inches. That's a length. But in the problem, they call it a depth. So I would have the derivative of the depth compared to time. Do you guys want to see if you can write the third and fourth one on your own? So I guess vehicles is kind of a weird one to label. Whatever you called it is fine. I didn't want to put V because I didn't want anybody to confuse it with volume. But you can label anything however you want, as long as your derivative labeling matches up with whatever you label it. So these should have been kind of straightforward. D vehicles per DT is 85 vehicles per hour. Number 4, the only difference is it's escaping, so that's a negative volume. I guess you could label it as positive depending on your viewpoint, but no, the volume of the balloon is getting smaller, so it'd have to be negative. I don't know. I'm assuming the bottom 2 went okay, though? Okay, then let's go right to the main section of this. So all of the word problems we're going to be working with, every one of them has a different kind of formula you're going to be using. There is no set formula that gets used all the time, or, like, it's different every single situation. They're generally normal things, like areas, volumes, surface areas, lengths. The problem is it could be any shape. So it could be triangles, rectangles, circles, spheres, whatever. You're not expected to know every single formula. Okay? Normal formulas I would expect you to know, like areas, those should be pretty normal. You're going to be expected to know volumes of prisms. So I don't know if you remember what a prism is. A prism is when you have 2 of the same shapes connected. So like a cylinder, a tent shape, like a Boy Scout tent shape would be a triangular prism. You would be expected to know how to find surface area on regular solids and spheres, unfortunately. So a volume of a sphere is 4/3 pi r cubed. Anything that's irregular. So, like, you're not going to be expected to know the area of a hexagon or something strange like that you use once every 3 years. Irregular things, the formula would be given to you. So, on past AP tests, on these style questions, that's how they kind of set it up. If it's a regular shape, they kind of expect you to know how to find it on your own. But if it's uncommon, then they just immediately give you the formula to work with. So don't necessarily stress about formulas other than regular things. And I'm sure you might have to look some of these up. That's fine. On the test, I'm gonna hold it to regular shapes like circles, rectangles, triangles, things like that. Okay, area of a rectangle. Every single one of these questions, we're going to be doing the derivative with respect to time. So we're going to be taking d dt of the whole formula. I don't like L's because it looks like my ones. Do you guys need refreshers on this? Okay. So derivative of A is just going to be derivative of A. How would I take the derivative of the right-hand side? I'm hoping it kind of sticks out to you. Product rule. Because I've got 2 variables being multiplied, I'm going to have to do product rule. So derivative of LW would be the first times the derivative of the second, dW dt, plus the second derivative of the first, dL dt. Most of these equations are not going to come out nice, especially because we traditionally will be taking derivative with respect to time, and time is never going to be one of the variables. Like we record things with respect to time, but that's not like a variable we're going to plug in. So most of these work out kind of strange that way. Up above, you see how we were kind of labeling things like you were able to record or measure that air was leaving this balloon at 15 cubic centimeters per second. So as we're doing these problems, if we have a problem with the volume of the balloon, we would put negative 15 in place of dVdt. Okay, circumference of a circle, 2 pi r. Now, I partially wanted to go through and fill out all of these because if you guys have a problem in your homework that involves one of these, then you can kind of just directly take it from your notes. Should I start calling on people? No, not yet? Oh. Okay, derivative of c, circumference, dc dt. Ooh, now we finally run into numbers. I'll take a volunteer. Does anybody think they know how to do the derivative of 2 pi r? I don't want to put anybody on the spot for this one. Yeah.
Is it 2 pi times dr?
Would it be 2 pi r times dr dt?
Did you just rewrite the exact same thing?
Yeah, like 2 pi r times the derivative of r.
Oh, got you. And then you said 2 pi times dr dt? Okay. How should I say this?
No, it just went 2 pi.
Oh, now you're changing yours? No. Oh, okay. What would be the derivative of 5x? Just 5, okay. And then when we started running into derivatives that weren't x, the derivative of 5u would be 5 times u prime. So the first derivative we take kind of like normal, like we treat it like it was an x, but then because it's a different variable, we put this at the end. So the pi ones are the weird ones because pi feels like a variable to you. But 2 pi is just a multiplier. So the derivative of 2 pi r will be 2 pi times the derivative of r. You were right, Andrew. I wasn't trying to make you feel like you were wrong. And I'm assuming you got kind of stuck trying to figure out what the variable part. Yep. Yeah, the first time you work with the pi ones, it feels off. Are we okay with that derivative up there? Certainly ask away if you just don't understand it. Okay. Volume of a cube. What's going to be the volume of s cubed? Or the derivative, not volume. What's going to be the derivative of s cubed? Let's go with Caden. Last in, first up. Wait, we should definitely make that a thing. I feel like that would be a great motivator to get you guys here on time. Last in, first up. Okay?
Would it be 3s squared? And then, yeah, it's like that.
Oh, you were doing excellent up in there. When you started to say and then, that's when I thought you were going to finish it correctly. Because this part was perfect. Like you do the derivative like it was an x or something, but then we're taking the derivative of s compared to a different variable, so ds dt would be at the end, like s prime. No, you were doing perfect. Once you get the hang of these, then they all feel the same. Do you guys want to try 8 on your own?
Sure.
And then Caden's gonna tell us who's gonna answer it? Maddie, I feel like you get a reprieve for a day or two at least.
Oh.
You need probably time to catch up and re-soak in a lot of info.
Yeah.
There's two ways this one can be done, by the way, so even if you did it slightly different than the person next to you, it doesn't mean you're necessarily wrong. Caden, who's gonna help us?
Luke,
Luke? He's already answered today.
but he's really smart.
True, but he's already answered. We wanna like pass it around.
What you pick someone? I got one.
Who's second last? I can't remember.
I'll give it a go.
Really?
Yeah.
All right.
Would it be 2 pi times r? Or I would do the product rule for the r and h.
Mm-hmm.
So times r times the derivative of h. Yeah, okay.
It's very hard to fit this in here.
Is that correct?
It is correct. You forgot the left-hand side.
Oh, ds.
Yeah. So I don't know if you just focused on the right because that's where all the work was. But perfect. So the other way you could have done this is you would treat 2 pi r as the first item and then h as the second one. And I don't know which way you guys chose, but absolutely this way on the left is correct. So ds dt would be the same on the left of both. It's pretty much just like if you were to multiply out this 2 pi r. So the derivative, or no, 2 pi r would be the first, dh dt the second, h, and then the derivative of 2 pi r would be 2 pi dr dt. And it really doesn't matter how you want to handle it. I prefer the one on the left only because there's less stuff to write. Just kind of curious, which way did you guys do? Like, who did the one on the left? Did anybody do the one on the right? Oh, wow, okay. All right, split. All right. So does that mean these are going pretty good? Should we kind of move to the later ones? I guess 12 is probably the worst one. Why don't you try 12? If you could do 12, you could probably do any of them. Mandy, I think you took your test before break, I think, right? Yeah, okay. Perfect. Maria, you're looking confident. Do
Okay.
you think you have this one?
Yeah. Okay, so dv over dt.
Oh, wait, that's an eraser. dv/dt.
It said equals 2/3 pi r.
So did you treat 1/3 pi r squared as the first thing?
Yeah.
Okay.
And then h is the
2/3 pi
second.
r.
Times dr over dt. Times h. Plus 1/3 pi r squared. Times dh over dt.
Perfect. Boy, that's a lot of stuff. The other version, if you treated 1/3 pi as just a multiplier, then you would just do 1/3 pi kind of like this. R squared dh dt plus 2r dr dt h. I mean, they're basically the same thing, but those would be the two different ways you could do it. I'm impressed. I thought you guys would have a little more problems with it. So this is seemingly okay. I like it. Maybe what we'll call homework is for you just to finish filling out the rest of these. So then that way, when you run into the problems in your notes and the homework, you can just take the derivative formula straight from this page.